we've noticed that the a power descends, the b power ascends, goes up, and then we had to figure out what these numbers, the coefficients, were. Well, b to the 4 was just b to the 4. I don't know why I left this gap, but these have a gap. If we remember, it was an addition of the two above it. They kind of add down, and this addition thing was called, well, Pascal's triangle, if you remember from yesterday. So we 1 plus 3 gave 4, 3 plus 3 gave 6, and 1 plus 3 gave 4. Again, that continued on and on and on. I'm going to do one more. And these are the main 5 reference ones that we're going to use today. These are like, you can always fall back on them. And you should, by the end of this unit, you should be able to recreate this pretty fast. Any of these lines. But anyway, a to the 5. Maybe I'll just do the powers first again. A4 to the b, a3, b squared, a2, b cubed, a1, b4, and the last one's going to be b to the 5. Then I can start adding. 1 plus 4 gives 5. 4 plus 6 gives a 10. 6 plus 4 gives another 10. 4 plus 1, excuse me, gives 5. And then just plus b squared. Okay, so that's the first 6 expansions of binomials. And this isn't the binomial theorem. We haven't got there yet. But this is called binomial expansions, where you just have 2 general terms, a and b, and then, like we did at the end of yesterday, we can apply that then to further questions. So let's look at how we apply these to another question. Let me write the question here. Okay. So, find So I want to find the binomial expansion of this tricky looking thing, x minus 2 divided by x. Okay, a couple of things are an issue here. This would be a difficult example now, difficult question. Problems could be this fact that it's negative here and that we're dividing by x here. That's a problem, but we still just have 2 terms. The first term is x, and the second term is 2 divided by x. If you feel like you're confident going for this, just jump straight in and see can you beat me to the answer. Okay? All right, now it's to the power of 5. And once it's to the power of 5, I can use one of these reference expansions. I'm going to use this reference example because it's a and b, 2 terms to the power of 5. Okay, so it's going to look similar to this expansion, but instead of a, every time I'm going to put in x. So this x will become a, and negative 2 divided by x is going to be b. Just in this expansion. That's my first step. That's all I need to do with these binomial expansions. Once I know the general one, I can just replace a and b. So let's get to that. So the first one is going to be a squared. So a is now x, so it's going to be x squared. I'm just going to write what I am expanding again. This is my expansion. I'm going to use the general. So a is x to the power 5 now from here. The next term is 5, so plus 5 times a to the power 4, which is going to be x to the power 4. And now it's our first use of the b term. And it's just b. And b is negative 2 over x. Okay. I really hope I've left myself enough space here. I probably haven't. But anyway, let's see how we go. I'll write a bit smaller. The next term then is going to be plus. So all I'm doing is a substitution here. all I'm doing is replacing a and b. So a, again, I'm using my reference the whole time. I got the 10 from here, and then it's going to be a cubed, which is going to be x cubed. It's going to be negative 2 over x for b squared. Then I'm going to do it again. Once again, replace a and b. So it's going to be 10. A is x squared this time, and b is negative 2 over x cubed. And I have run out of space, of course. Plus 5. I will use the miracle of a second sheet here. Plus 5 is the next one. 5x. And then minus 2 over x is going to be to the power of 4. And then plus minus 2 over x to the power of 5. All right, so that's a very long problem. All right, now at this stage, I've done the substitution. All I need to do now is tidy this up and use the rules I know of indices and multiplication with algebra, and hopefully it'll all just come out and tidy up nicely. Well, let's see how it works. Step by step. First one, x to the power 5. Well, that's still going to be x to the power 5, so I'll leave that as is. The next term then, well, plus times a minus. I see a minus in here, so I know it's going to be a negative term. X to the 4, but it's also divided by an x. So one of those x's is going to cancel out with one of these. So instead of multiplying by x by itself 4 times and then dividing it by once, it's just going to be 3. So it's going to be negative x cubed, whatever it is. And 5 times this 2 gives 10. And it was negative 2, so it's negative 10. That's that term simplified. Hopefully you follow that.
Sir, I think you need to put the paper a little bit, the camera down.
Oh, sorry.
Yeah, okay, thank you.
Yeah. All right. Next term. Follow it on my other screen a bit more. Next term then. Okay, so once again, let's do the numbers first. Well, this is a little bit tricky. 10 and this negative 2 is squared. So negative 2 squared is positive 4. Positive 4 times positive 10 gives positive 40. Okay, so that's the numbers. X cubed divided by x squared. So remember, this whole thing would be squared. So if I were to do that just separately, minus 2 over x times minus 2 over x, that would just give minus 2 times minus 2 gives 4, and x times x gives x squared. So that's what it would look like, this one. But x squared then and x cubed, one divided by the other, subtract the powers, we're just left with an x, I think. Okay, that's the second term, or the third term. The fourth term then is this x squared and the x cubed. Now, cubed, 2 cubed, 2 times 2 times 2 is 8. Minus 2 cubed is going to be minus 8, because that's a 3 negatives. So an odd number negatives. Minus 2, minus 2, minus, yeah, odd number negatives. Minus 8 times positive 10 gives me a minus 80. Now what about the powers here? X squared is on top, but x cubed is on the bottom. So that would be 2 take away 3. So that's x to the minus 1. Well, there's two ways of writing that. I can write that literally x to the minus 1, or I can put that x back down here underneath the 80. This is testing your rules of indices from GCSE. All right, that's that term done. Next term, well, hopefully you're getting the hang of it now. Maybe I'll speed up. Minus 2 to the power of 4, that's minus 2, minus 2, minus, I think that's 16, positive 16, because it's to an even power. So plus 16 times 5. 5 times 16 is 80. 80 as well, and it's positive 80 this time. It's also going to be dominated by this x4 below the line. So x divided by x4, subtract the powers, we're left with x3. And then our final term then is going to be negative. Negative 2 to the power of 5. Well, that, if the last one was 16, this must be 32. It's going to be negative 32 because it's an odd power. And it's all over x to the power of 5. There's nothing to cancel anything with. And this is our answer. Can't expand it or simplify it any more than that. So what I've done is I've used this reference line up here, just replaced the 2 in the binomial. Instead of A, write this, instead of B, write that, and then expand. That's how, for the moment, we're going to do binomial expansions. We're going to use one of these reference, I'll scroll back up in a second, one of these reference multiplications, which if you don't have in your notes, have in your notes, because you're just going to be using them. Okay. Any questions on any of that? All right. Let's go through what you need to do now. I'm not going to do any more new stuff. That was kind of just finishing off what we did yesterday. You did some similar questions yesterday. Let's have a look at what you need to do today. So I'm going to switch back to my other screen. Okay, so I'm on this screen now. Let me just share my screen again. Okay, so this is the work you have to do. I think you have a PDF, not this Word document. All right, so the first question, use the binomial expansion of a plus b cubed. That's the third line binomial. This should be pretty easy. So instead of a and b, just use p and q. Instead of a and b here, use x and 1. That should be pretty straightforward. This is a bit like the question we just did. Use this line, so they've written out the line for you to expand and simplify this. So once again, replace, substitute in, just like we just did. Both these, this would be a little bit trickier because it's got this 1 over x, but I'm sure you're able to do it. So question 1 and 2 should, I would imagine, be pretty straightforward. Question 7 and 8, not quite as straightforward. This, I haven't got the reference line for the 6th line. Maybe you have it in your notes already, but maybe you have to figure that out first, then do it. And then for part B, I'm not going to say exactly how to do this, but 2 plus what is 2.01. There's your hint. 2 plus something is 2.01. So the something will go in there when you have expanded, and then maybe you can find a value. Question 8 then is looking for you to use a binomial expansion here with the 4th and the 3rd one, and then afterwards multiply that expansion by this and this. So do the binomial, do the power first, and then do the multiply afterwards. That's my hints for those. So that document is on ManageBack. If it's not there, maybe just refresh your screen. Okay, so you guys should get 6 and 7 done and attempted 7 and 8. If give a go with 7 and 8, but the first two questions, 1 and 2, they should be pretty straightforward. So give those a go. We'll check your work tomorrow in the in your workbooks, or if you're working online, just